We're asked to use this information to find a p-value. They give us a test statistic, and they tell us it's the z-distributions. So the alternative is that proportion is not equal to 0.377. So that does not equal to simple is actually key there. What that means, as soon as I can get my computer to load, you have a two-tailed test, okay? So the p-value is split between two tails. So they're testing the right? This is like 12 out of 100 or something like that. The proportion does not equal some value. So does not equal means you have a two-tailed test, and so your p-value is the area in both of these tails. That would be a one-tailed test, and the p-value is the amount of the area that's in this tail. Okay? Because a p-value is the probability that you get this test statistic assuming it's just different. It's either less than or greater than. That's why it's two different tails. So that's important when we use stat disk, or depending on how you we want to use z equals 3.06. So let's go to analysis and stat disk, probability distributions, and then it's z, so this is a normal. The z value we have is 3.06. If you hit evaluate, then it tells you the, actually, no, that would be for something else. A z value, that corresponds to a 0.05 tail or something. So it tells you the left probability of being less than this, whatever the z-score was. This is the probability of being right. And like we said, we have a two-tailed test. So the p-value for this test is, got these numbers, assuming that there's no effect happening, is low. It's 0.0022. The area of these tails is 0.0, keep forgetting the number, 0.0022. So if the p-value is low, if it's below the significance level, that means it's very unlikely the null hypothesis is true. We're going to reject it in favor of the alternative hypothesis.